In this slide, we'll be discussing a valuable aspect of web application security, XSS WAF bypass. The focus here is on identifying a single payload that can effectively exploit cross-site scripting vulnerabilities across various web application firewalls, WAFs. We will explore different techniques used to bypass these security layers, allowing for the injection of malicious scripts. By understanding these methods, you'll gain insight into how attackers might compromise web applications, and you'll be better equipped to defend against such threats. Now, let's explore some common methods for bypassing web application firewalls, or WAFs. These strategies are instrumental in understanding how attackers might circumvent these security measures. First on our list is the Cloudflare bypass technique. By prefixing JavaScript events with "on," attackers can evade detection. This subtle modification can slip under the radar of many security systems. Next, we have double quote injection. By using onroar.js for cross-site scripting when double quotes are permitted, this method takes advantage of certain leniencies in the security configuration. Lastly, character prefixing is another method where adding an extra character before event names helps to bypass WAFs. This simple trick can often fool defenses designed to recognize specific malicious scripts. These methods highlight the sophistication and creativity involved in WAF bypass techniques, underscoring the need for robust security practices. This slide focuses on techniques involving quotes and entities for bypassing web application firewalls, or WAFs. The first technique involves using an odd number of quotes, which can help bypass these security measures but will typically result in invalid syntax within your code. To counteract this, one might incorporate entity aliases. By replacing middle quotes with entity aliases, it becomes feasible to craft a WAF bypassing payload that maintains valid syntax. Additionally, there are various HTML entity types you can leverage, including named, hexadecimal, and numeric entities. Each of these can be used to create effective bypasses, providing alternative ways to encode characters that might otherwise trigger WAF detection. On this slide, we explore various techniques for manipulating entities to bypass web application firewalls, WAFs. We'll start with named entities, where you can use aliases such as for quotes and ast for angle brackets. This method allows you to substitute potentially harmful characters with their corresponding named entities to avoid detection. Moving on to hex entities, you can represent quotes as A and angle brackets as lay. This method utilizes hexadecimal codes to achieve the same effect. Lastly, numeric entities can represent quotes and angle brackets using an il, respectively. By implementing these entity manipulation techniques, you can craft payload effectively bypass security filters while maintaining valid HTML syntax. In this slide, we'll cover advanced techniques in entity manipulation for evading security measures. One strategy is zero padding with numeric and hex entities. This involves adding zeros to these entities, which can help in bypassing filters that don't recognize them due to their altered format. Another method is the use of remote script loading. By importing scripts encoded with entities, one can potentially load external and possibly malicious scripts discreetly. Finally, there's the technique of using base64 evaluations. By encoding large sections of potentially harmful code within base64 and then decoding with entities, it becomes much harder for standard security systems to detect and intercept. These methods can be potent in sophisticated attack scenarios. Hence, understanding their application is vital for security professionals to anticipate and mitigate such threats. In this slide, we are focusing on strategies for bypassing web application firewalls, or WAFs, specific to certain providers. We'll start by examining payloads designed for Imperva and Encapsula, where the technique involves utilizing HTML details and open tags with a specialized ID attribute. The inclusion of JavaScript within these tags is a common tactic. Similarly, for Amazon and CloudFront, a similar approach is used, again leveraging JavaScript within these structured tags to bypass security measures. When dealing with Akamai, an additional layer of complexity is introduced. This requires extra quotations around particular attributes to effectively obfuscate and evade detection by the WAF. Each of these techniques is crafted to exploit the specific architecture and rule sets of these WAF solutions, targeting their unique vulnerabilities to succeed in bypassing them. In this slide, we're focusing on the methods to bypass Imperva and Encapsula web application firewalls. The key approach includes manipulating the payload structure using the details tag. By incorporating the open attribute along with an ID parameter, we create a vector for malicious activity. Furthermore, we can insert a entity before the on-toggle event, a strategic move that aids in bypassing WAF defenses by altering the expected structure of the payload. Lastly, executing JavaScript adds another layer, allowing the potential for further exploitation through malignant code positioned after the on-toggle event. Understanding these nuances enhances our capability to assess and test WAF limitations responsibly. Now that we've reached the conclusion of this section, it's important to emphasize a few key points regarding Web Application Firewall, or WAF, bypass techniques. First and foremost, security awareness plays a critical role. It's essential to stay informed about the latest bypass methods to enhance your defenses against potential threats. This involves keeping abreast of evolving techniques, constantly improving your understanding and readiness. Equally important is the concept of responsible testing. It's imperative to apply these techniques exclusively on systems you either own or have explicit permission to test. Unauthorized use is both unethical and illegal, and it's important to adhere to the guidelines of responsible security research. Finally, continuous learning is necessary due to the dynamic nature of WAF technologies. As these systems advance, so too must your techniques and understanding. This demands ongoing research, adaptation, and refinement of your methods to stay effective and relevant in the field of cybersecurity.